So I guess the first question we'd like to explore and have somebody respond to it is automotive and electronic industries continue to leverage robotic technology, but what other industries are starting to create competitive advantage applying robotics?
Food and consumer goods, as well as pharmaceuticals, are seeing a lot of growth in the robotic marketplace globally. We're seeing it pretty much everywhere. And that's because the merging of technologies are enabling robots to work in that environment where they may not have been able to work in an environment just a few years ago. Merging of technologies such as vision, high-speed line tracking, along with compact high-speed robots and the communication system to get the information from the camera to the robot control system to find the product that you're trying to pick off of an unstructured environment has really assisted the implementation of robots into that in that market space.
Excellent. What kind of opportunities are there for robot applications with the merging or integration of vision technologies and imaging recognition software with robots?
Already back in the early 80s, the management at that point in time were convinced that integrated solutions with vision, every robot should have that. And the interesting thing is we are still sitting here now 30 years later almost, and we are kind of now getting into it. I think the cost-benefit situation has been preventive to a large scale, but there is no doubt in my mind that with some of the technologies that has to do with calibration and things, and if you have integrated vision, it's going to dramatically change the map for robotics going forward.
Perhaps the time lag has been because the idea was there, but the technology really wasn't available to support that at the time.
Yeah, absolutely. I mean, I think the technology has really moved forward. You know, vision is a very computation-intensive activity, and you know, if you look at the exponential curve of microprocessors over the last 2 decades, vision is one area in robotics that's really taken advantage of that curve, and it really enables the ability to operate at high rates of speed. You know, Kevin mentioned food, which is an area of focus for my company. You know, food, you have applications where products coming down a line at hundreds or even thousands of product a minute, and you know, the robot needs to make very, very fast decisions and be able to, and the vision has to process that data in real time, and you know, that only is possible because of technological advantages.
Let's kind of shift a little bit. Considering the industry has come back from a period of sales or application being very down, now rebounded, will there be any other crises you could foresee in the future now that we've been broadening the number of application areas for robots?
So my comment on that would be that seeing the fact that the robotic coverage and the coverage of more and more application fields is getting wider and wider, the chance to have, or the risk to have such a crisis which affects all these areas is decreasing.
Mr. Shepard?
Yeah, I think the crisis that's related to this is the fact that we're already seeing a shortage in applications engineers, people who are able to apply the technologies, because there's many technologies that are out there and available today that can be clearly implemented, but the challenge is finding the companies who have the manpower that can either hire the additional manpower or train the additional people to apply the technologies that are already there. And then, frankly, there's a lot of the students today who've moved away from looking at careers within robotics and manufacturing and other places because they don't see it as a safe place to have a long-term career.
That actually follows another question I have here, and that is what's being done to make robotic technology easier to apply, which would broaden the industry, address the issue you have about talent, and also many other industries may be able to take advantage of it.
So we are just looking at the mass production solution. So and then we are changing the mind. So our field inspection is for robot is the multi-skilled solution for minimum volume production. So that is maybe I believe that is the effect to the risk coverage for the economic go down, up and down, and flexibility can be achieved by robot solution. So robot solution is a more flexible solution with manipulator also intelligence. So that is our future's target. I think that is my opinion.
Let's kind of move on to something a little broader, and this has to do with acceptance of technology and also application, but do we need robots to facilitate the tasks of the aging workforce?
Yeah.
One of the challenges is there's a huge number of people going to be retiring from the workforce in the next few years, and the number of workers to come in to replace those spots is going down dramatically. So part of the challenge is to get the robotic automation to fulfill those roles and perhaps become more expert systems oriented, to become the future welding professionals or the future automation professionals in certain applications. The drive towards the robots being able to be more autonomous and think more applications related than what they've been in the past is going to become very important. So not so much on general robotics, but application-specific robotics to address the needs of these highly skilled workers who will be leaving the workforce.
When you look at manufacturing, productivity is measured by output per labor. You know, and the best example of that is the United States is the most productive nation in the world. You know, we produce more goods and services than, you know, China is a good example, with 1/10 the workforce. Mm-hmm. You know, and that really is the value proposition that robots bring, is the ability to be able to accomplish far greater levels of tasks with a much lesser amount of human intervention. You know, and certainly you can fast forward that into elder care and how robotics are going to have to play a major role in helping us support our aging population, or, you know, the economy is just going to implode on themselves. So
I think maybe move on to a simple question. This will be easy. When are robots going to be as easy to program as an iPhone?
Yeah.
Obviously, an iPhone is a complex device and very easy to use, but it's not nearly as complex as a 1,000 or 2,000 or 3,000 pound device manipulating parts through space in an environment with people present. And so I think the things that you're going to have to see there first are safety systems. There was a little bit of mention of that in Oki's speech. Safety systems have to be there so that the work environment is more conducive to people and robots working together. The other thing that everybody continues to work on is the graphical user interface, or the teach pendant, or the device that you use to monitor the system and what's on that device. That's broadening more and more, where you're not controlling just the robot, you're controlling the cell, you might be controlling the line. And through one device as opposed to multiple devices, you're not, as much as you used to, going to multiple controllers to do different tasks of a similar nature within the same environment.
More integration,
consolidating
simpler to
that,
use.
more integration.
If in the robotics you solve a lot of other underlying technology issues, like has to do with calibration and variation of the parts, and if you have kind of predefined tasks in the background where those technological things are already solved, then you can get closer to work like an iPhone and pick and have those choose. And maybe robots can even by themselves decide in what order to do certain things and certain tasks. But as Kevin said, it's much more complicated in a way. And, you know, I always used to say, and I'm going to take the chance to say it again, we many times think of how to program the robot, which means that you can easily get stuck in that mindset. You need to look at it from the other way around. How can you make the robot do what you want it to do? That's how you need to think.
yeah. You know, and I think as you start to think about where these consumer electronic technologies play, they'll play in applications where a lot of the complexity is simplified. You know, and in the case of a mobile robot, its world's much simpler than it is an industrial robot. And, you know, it will take time for that to cross that bridge in the industrial space.
Well, let's move on and have each panelist comment on a question we have. And that is, what is the most important incentive to use industrial robots in the manufacturing industries? Maybe we'll just start at the beginning here.
Okay. The most important thing, of course, is the consistent quality and productivity. And if you produce with consistent quality and you have a high productivity, that means you're going to be most likely competitive. You have a chance of being competitive. And then you have stay power. And companies who have stay power, they don't go bankrupt. They prosper and they employ people.
You know, I think that the other enabler that robots provide is an ability to bring a consistent manufacturing strategy globally. You know, the reason China's the fastest growing robot market now, you know, isn't because China wages are expensive. It's because robots are proving that even in low-cost labor markets, they're cost-effective. You know, and I think if you think in the long run, it doesn't make sense as a manufacturer to produce your goods by chasing where the cheapest labor point is. It makes sense to produce your goods in the best logistics spot for your markets, and that's what robots will enable in the future.
Mr. Go.
Okay. Robot is different from the iPhone, but that is the open source solution is very important for the future. So because we are looking for the many applications in the world for some compensation. So and then many applications mean the software described some application, not only the robot skill but also some additional functions. So that the open source ideas should be expanded in the world, and also existing the productivity, quality, and the low cost. Also together is very important, I think.
Yeah, Mr. Adsby.
Yeah, I echo the thoughts of the three prior panelists here, that its cost and value, reliability certainly is a big key as well. They run and run and run, and they work all the time, and no breaks, and so your productivity is enhanced. One interesting story to talk about the cost proposition or the value proposition is I was in Brazil in a factory, and about 3,000 workers in this factory making a very simple product that you would find in any drugstore, grocery store at any point in time. And I said, what do these people make? And they said, it was about $7 a day at that point in time. I said, why in the world are you looking at automating? He says, because we have to be competitive with China.
No.
So it was not a matter of what they were paying their workers. It was they had to put robots in to improve the productivity of their operation and improve the quality of the parts being produced.
We'll have to talk about that never breaks thing later that you mentioned there.
Well, they do break, but not very often.
Well, Mr. Engelberger said over 50 years ago that one of the reasons for doing robotics is certainly things have been discussed so far, but also redeployability. And I think we've proven without a shadow of a doubt that industrial robots are reliable and can be redeployed and reused and drive this issue of flexibility that we've been discussing for years. The other thing is we're still able to bring people out of dangerous and nasty work environments. Today we're removing people from environments such as X-ray or imaging radiation, or radiation being used for cancer treatments, and trying to keep the technicians and the patients safe.
Dr. Wenzel?
Okay, now, of course, it's hard for me as a last in the row. As we say, it has been said everything, but not from everybody. But just to bring it to the point, I would say the biggest incentive, and this is where the economy lives from, is to create added value for your customer. And I think if you can create adding value for your customer by increasing his competitiveness, that's a driver, and more or less this refers to what you said already.
Very good. I think at this point maybe we take some questions from the audience if we have some.
The Robonaut presentation this morning showed the value of the hands and their complexity, and the two-armed working with humans. Do you see that as a big trend?
Yes.
Yeah.
One of the most complex and expensive things in that whole product is the hand. I mean, there's more motors in the hand and more actuators in the hand than there is in the rest of the robot. So it's creating a hand is a remarkable piece of technology. Getting it to a point of cost and reliability is going to be a real challenge. I think the second thing is do you design robot hands or arms to mimic people, or is the end-of-arm tooling of the robot going to be purpose-built for the application? And if you look at lots of things we do in manufacturing, hands are not the optimal solution. You know, there's a much better tool, and really, if you look at it, hands are pretty useless without tools.
Will we have a situation when vision systems become higher performance, smaller, more economical, and more widespread?
One of the things that we focus on has been the speed at being able to process the information coming from sensors in general, vision being one of them. The other challenge is as we become more and more diverse in our applications, the types of vision systems we may use may become more and more diverse. They may be X-ray based or laser based or other types of structured lighting. So it's difficult sometimes to pick one system to embed into your product that matches all expectations.
We'd like to thank this knowledgeable panel for sharing their ideas and insights.